Hello, so let's look into today's Leetcode problem, and the problem goes like this. So here you are given with a 2D matrix, and you are allowed to do an operation any number of times, and the operation is basically to select any two adjacent cells. And by adjacent cells, what they mean is select any two cells which are horizontally adjacent or vertically adjacent. Here, these two cells are adjacent, these two cells are adjacent, but you should not consider diagonally adjacent cells. That's what they mean. So you select any two adjacent cell and do the following operation, which is basically multiplying -1 to each of the two adjacent cells, and in the end what you need to do is maximize the summation of all elements present in that matrix. So the question is pretty straightforward, and the approach would also be and I would say if you look into examples, like if you look into few of the examples given here, you would actually arrive into the intuition part also. So here what they are trying to do is, for the first example, um, they are choosing these two elements. They do the operation. The negative one will get converted into positive one, and here when you multiply it with -1, the -1 will come here, and you choose these two neighbors and do the same operation. In the end, you get a 2D matrix which is completely free of negative signs, and that will give you the maximum summation possible. In this question, we have even number of negative numbers, because of which we were able to get rid of all negative signs. But if you look into this question, this input, you will see we have odd number of negative signs present over here. And in that scenario, there will always be one element which will have a negative sign. You will get rid of all the even numbers of negative signs present, but one number which will always have a negative sign. In a scenario like that, if you want to maximize the summation of 2D matrix and that matrix still has a negative sign present, then you would want to do minimum damage, which is shifting the negative sign to the least element, minimum element present in the 2D matrix. In this matrix, 1 is the minimum element, so you would want to shift negative sign to that place. So that's what the intuition is. Um, One interesting thing that someone can note here is if the matrix has 0% in it. Let me draw it out once. 1, 2, 3, 2, 4. Let's say we have a 0 here. 5, 7, and then 2. Let's introduce negative signs in few of the places. Okay. So in a case like this, in a scenario like this, even if we have a total of three numbers of negative signs, we have a zero, and we can, abuse this zero as much as we can. So let's say the signs get shifted from these two neighbors. Like we do the operation and 7 gets a negative sign, and we get rid of the negative signs for these two adjacent cells. But for this one, we might not have a compatible negative adjacent neighbor. But what we can do is we can shift the sign to 0, because a negative sign when multiplied with 0 will still give you 0. So you do the operation, you select two adjacent cells, transfer the negative signs, and in the end, boom, yeah, the negative sign is gone. So that is one thing that you can observe over here. So yeah, that's it. The intuition is pretty clear. So let me write down the intuition. If negative elements mod of 2, total number of negative elements are even, then you return summation of all elements, all absolute elements, I would say. And if if negative elements mod of 2 equal to 1, then you do something else. But before that, if you find a 0, if 0 is found, then you can simply return the same, which is basically summation of all absolute elements. And if you find a negative element, you do what I said. Let me shift it down over here. The solution would be summation of all elements minus 2 times of minimum absolute value present in the matrix. And let me come into what it actually means. So let's say you do the computation. Let me draw it in a new space over here. Okay, let's say you make the negative, you shift the negative sign to the minimum element present over here. Let's take a smaller example so that we save time. We take a 2 cross 2 matrix. Yeah. So the answer would be minus 1 plus 2 plus 4 plus 5. And when we do our calculation, when we apply our algorithm, we let's calculate the sum of all elements present. That is absolute value. Then the summation will be 1 plus 2 plus 4 plus 5. And if you want to convert this result into this result, what you will need to do is subtract a minus 1 and again subtract a minus 1. Because here it's pretty quite explanatory. You can see here as well. So previously we were calculating the summation of all absolute values, because of which we added an extra plus 1. So we want to compensate here, and if you want to arrive into the actual solution, then you will have to add an extra minus 1 over here as well. So this is basically summation of all absolute elements in that matrix minus 2 times of minimum of absolute of that matrix. Minimum, it should be this way. Yeah, minimum of that matrix. So that's pretty much it. Let's look into the solution once. So what I try to do here is I set a variable sum, and when I do the iteration, I will add the absolute values of all the elements present in that matrix when I traverse through the array. Negative is basically the total number of negative signs you have found in the matrix. Here the flag represents the if the matrix has 0 or not. Initially we have set it to 0, and we have a variable minimum mini to store the minimum absolute value of that matrix. So here I do the traversal in the 2D matrix, and if I find 0 present in that matrix, then I set the flag to true. Then if I find a negative element, then I increase the negative count by 1. And when I do the iteration, I would want to set the minimum absolute value as well, so I do it here and calculate the summation of absolute values present in the matrix. Then if I find 0 present in the matrix, then I simply return the absolute sum of all elements present in the matrix. Else, if I find a negative number of signs, sorry, even number of negative signs, then also I return the same sum. Else, as per my explanation, we will be returning sum minus 2 into minimum. Here in the minimum code, I'm storing the absolute value only, so you need not worry about it. So yeah, that's pretty much it. Thanks for watching. Bye bye.